Oil and gas operators are turning to passive seismic monitoring technology to improve well stimulation results and avoid environmental hazards. Passive seismic monitoring helps oil and gas companies understand how the reservoir responds to stimulation. MicroSeismic events occur as a result of stress changes in the subsurface. Surface arrays are temporarily deployed during the period of the fracture job to collect data. The results help improve completions, determine optimal well spacing for field development, and assure environmentally safe well stimulation. Temporary surface arrays have a flexible design that enables crews to work around impeding structures, varying topography, permitting considerations, or other challenges. Each sensor has proven reliable in even the most extreme weather conditions. Surface arrays act like a stethoscope, passively listening to the sounds from the subsurface. There is no need for large, heavy vibrisized trucks or dynamite sources typically used in active seismic operations. Each surface array is deployed by a team of professional crews with minimal intrusion to the property. The crew's top priority is protecting the land and ensuring environmental sustainability. The use of tiny, temporary sensors ensures a minimal surface footprint. Here, we see a series of stations being laid out across the arm of a surface array, which tracks the horizontal wellbore below. Crews quickly deploy the temporary cables with a set of sensors strung together into stations along the designated arm. Each array contains approximately 10 to 12 arms distributed radially around the wellbore, with anywhere from 100 to 120 stations per arm. Acquisition geometry is resilient to surface obstructions because the stations can be laid out to avoid hazards. Once all arms are laid out, the stations communicate with the recording truck situated near the well pad to begin recording and processing the data in real time. Now, the well operator can begin stimulation activities. As the rock breaks, the resulting sound propagates to the surface, where the sensors detect the sound waves. The analog recording is digitized and transmitted to the recording truck. Crews in the recording truck begin monitoring the acquisition of data during the stimulation treatment and beyond, as required by the monitoring objectives. In real time, it is possible to detect if rocks are breaking in environmentally sensitive areas and quickly notify the operators to stop pumping. Monitoring also allows operators to see that groundwater aquifers are not penetrated. Here, we show a 7-well multilateral being monitored in the Marcellus. As the rocks in the reservoir begin breaking during well stimulation, data is gathered from the sensors and mapped to show where the fractures are occurring. The dots represent each point where a rock is breaking, and the different colors indicate the individual stages. The same results are being displayed on the right side of the screen, but in this perspective, it is possible to see the fractures are contained within a few hundred feet of the wellbore, which in this case is 9,000 feet below the surface. This is important because it contradicts a common misconception that fractures can propagate thousands of feet towards the surface, causing water contamination. In addition, real-time monitoring means that pressure pumping activity can be shut off should the need arise. The results shown here help the operator realize that by increasing their well spacing, they could reduce the number of wells to be drilled, saving hundreds of thousands of dollars and significantly reducing their overall environmental footprint. MicroSeismic technology provides transparency to the well stimulation process, assuring both operators and landowners that fracturing is being done effectively and safely. After the job is complete, crews retrieve all elements of the array from the property. The recording truck is moved off to the next job, leaving virtually no trace and no environmental footprint. A final environmental benefit of this technology is that identifying the fractures helps operators make their stimulations more efficient, reducing the use of proppant and water in many cases. MicroSeismic technology offers potentially significant monetary savings for the operator and improved environmental protection for all.